Okay. Most of us have green on the left, notes on the right. Thank you, guys. I see some property notes, like kind of in the way, and don't worry about it now. We're going to our regular chapter 5 notes, but if you have your notes in the way, just after class, just slip them behind your chapter 5 notes. That way they don't get in the way in the future. Okay, we're still going to use them, but probably should have them behind your chapter 5 notes. It'll help you out on future lessons. All right, here we go. Today, all right, this lesson is a pretty important lesson. As a matter of fact, I've actually spoken to the high school teachers, and they said that one thing that they would like for their students coming up into their class to really be good at is this skill right here. Now, your book calls it simplifying algebraic expressions, and that's ultimately what we're doing. But the specific skill we're really talking about, and that's kind of why I put it there as a heading, is combining like terms. Okay? So on the website and on the video, I'll probably label it to match the book, which is simplifying algebraic expressions. But what we're ultimately doing is we are doing something called combining like terms. Okay? So what I want to point out really quickly before we get started, we'll talk about what like terms are, but I have found that I probably should go over that word right there, combining. Okay, and when you had the lesson at the beginning of the year called combining integers, what we're ultimately doing is this. We're adding and subtracting. So what we're doing in this lesson is adding and subtracting like terms. Okay, now you've heard me use the word term before, here and there. All right, but like terms, you probably haven't heard me use. So we're going to talk about what those kind of things are, okay? So here is, for our vocab, here's our very first word, terms. Everyone? Oh, let's try better. We can do better than that. Terms, everyone? Terms. All right, so here's what your book says a term is. A term is a number, a variable, or a product or quotient of numbers and variables. A number, a variable, or the product or quotient of numbers and variables. Okay, so I'm going to give you guys examples of every single part of that vocabulary, the definition. Okay, and here we go. So in your little box, 8, just the number 8, that is a number, and that's also called a term, a positive 8. The variable x, just x by itself is a term. It's a variable, so it's also called a term. And if you take a look, right, these are all separated by a semicolon, but there's a number, a variable, and then look, a product of a number and variable. What that's talking about is this right here. Here's a number, meaning a -3. It's a negative number, it's still a number, an integer. -3 times y, or better known as -3y, is called a term. Those are all different terms. And then the last one is a quotient of numbers and variables. And the way I want you to write this in your box is p divided by 2, p over 2. That is a term. So those are 4 different terms. Okay? In earlier lessons, right? Terms. That's what we talked about when we corrected our homework. Okay? Question on terms? Okay. Our next word is constant. Everyone? Constant. All right, so a constant is a term that does not contain a variable. A term that does not contain a variable. Well, guys, if you take a look at these 4 examples up here, these 4 terms, which one does not contain a variable? 8. 8. So guys, watch this. A constant is a number. You could say an integer. That's what a constant is. So, for example, 5 is called a constant. -9 is called a constant. If it helps you remember, bless you, in AB class, the word constant means like all the time or even every time. It's constant. It doesn't change. Okay? Well, here in contrast, watch. Here's what it is. In problem 1, if you solve for p, maybe p is equal to -1. But maybe tomorrow, on another homework assignment, p might be equal to 126. Depends on the problem, right? It changes. But guys, that number right there in kindergarten represents that. In 8th grade, next year, it will represent this many. That number right there, right now, in problem 10 is that many. Or problem 26 is that. You guys get the idea? It is always the same. It always has the same value. That's why it's called a constant. Okay? When it has a variable, the value is going to change from problem to problem. And a lot of times we don't know what that value is. We'll have to be solving for it. Okay? So that's why a constant. And you'll hear these words a lot as you get older in math class. Okay? Even in this chapter, you'll hear them all the time. Okay. The next word, we talked about terms. Now comes the word or the phrase like terms. Everyone? Like terms. So what does it mean? We know what terms are, but what makes them like terms? To put that like adjective in front of the word terms, like terms. Well, here's what the book says. These are terms that contain the same variables raised to the same power. Terms that contain the same variables raised to the same power. So like terms can also be numbers by themselves. Okay, so that's something else you'll need to know. Like terms can also be numbers by themselves. So here's, for example, and I'm going to give you a long list of like terms, and I want you to write them all in the little box. Okay, here we go. So the terms m and 9m. M and 9m. Those are like terms because they have the same variables. And it says raised to the same power. We don't have to worry about that yet, but they are to the power of 1, just where you know. They're like terms. They have the same variables. The next set, the numbers 6 and 8. They're like terms. Now, they don't have variables, right? But look, it says like terms can also be numbers by themselves. So, two constants, 6 and an 8, those would be considered like terms. Then we have something like -2y and +7y. Those are considered like terms because they have the same variable, y's. Now, if you notice, I also give a little other example, kind of a counter example, as you will, that says not 4m and 7y. Those are not like terms because they don't have the same variable. Okay. Now, one more vocab word. All right. And this one you guys have seen before in directions, but I want to explain what it means in this lesson or in this chapter. Here we go. The phrase is simplest form. Everyone? Simplest form. So what does it mean when you're talking about expressions? What does it mean to be in simplest form? Okay, here it is. An expression is in simplest form when it is replaced by an equivalent expression having, and there's two conditions, no like terms and no parentheses. So if you have an expression and it has either like terms or parentheses, you know it's not in simplest form. There's something that can be simplified in there. Okay, and we've talked about both of these, right? We're now, of course, talking about like terms. We've talked about like distributive property with parentheses. And that's the whole reason why you learn distributive property in 7th grade, because when you get into higher math, if you have parentheses and you can do distributive property, you have to do it to get rid of the parentheses. It's not considered simplified. Okay? So, for example, here's some other examples. Simplest form would be something like 6x plus 5. There's no parentheses. These two do not have, they are not like terms, right? One has an x, the other one is a constant. Okay? However, here's two expressions that are not in simplest form. 2y plus 5 plus 4y. 2y plus 5 plus 4y. That's not in simplest form. You can simplify it. Okay? You have two terms here, the 2y and the 4y, that have the same variable. You have like terms. So it can be simplified. Another one is this. 4, and then in parentheses, 3n. You can actually simplify that. That's not in simplest form. Okay. Now, I'm going to go ahead and, first of all, any questions on the definitions of the vocab words? Okay. Now, before we go on, and you can write these down if you want, but you don't have to. I want to pose this next question. This is what's important about this lesson. Okay? This kind of implies it. It says, why do terms have to be like to add them? Why do they have to be like terms? Believe it or not, that implies, of course, that if they're not like terms, you can't add them. Okay? So, let's talk about this. All right? What if I put something like this down? Y plus 3y. Now, remember, we talked about this in the last lesson. Y is just y, of course. Bring down this plus sign. And then 3y can be expanded, right? As in y plus y plus y. Well, guys, if we simplify this, what do we get? 4y. How about this? 4x plus 2x. Well, let's talk about this. We have x plus x plus x plus x. Bring down this plus sign, right? And then 2x would just be x plus x. So what's that equal, guys?
6x.
Now let me ask you guys. We have 4x plus 2x equals 6x. We have y, or remember we talked about this, 1y plus 3y is equal to 4y. Now you guys a lot of times really enjoy quick ways of doing things, like algorithms, just rules, math rules that come from stuff like this. Instead of me making you write all of these x's out or all these y's out to solve your answers in this lesson, does anyone know of a quick way to take a problem like this to get an answer like this? Or take a problem like this to get an answer like this? Okay. Anybody? Jaden, you told me a second ago, I think it was this one or one of these, you gave the answer before I even expanded out. I think it was this one here. How'd you do it?
I added 4 plus 2.
Okay. What Jaden just described is he added this, here we go, coefficient, right? A former vocab word. This coefficient, the number that's in front of the letter, that's our variable, that's being multiplied with it, with this coefficient to get this coefficient. 4x's plus 2x's is 6x's. Ladies and gentlemen, does that work here? 1 plus 3 equals 4? Yeah. Guys, that's how you combine like terms. So if I give you guys something like this, what about this? 4m minus 2m. What do you guys think you get?
2m.
5m minus 2m? 3m. What do? We just take the numbers, 5 minus this coefficient here, 2, to get 3m. Sorry, guys. And I'm sorry that that wasn't on there. I was wondering. That's why I repeated myself, because I figured when everyone said the wrong one, I was like, oh, they know how to do subtraction. What happened there? All right, so let's try another one since you guys couldn't see that. How about this one? Oh, I'll make it a hard one. 9v minus 4v.
5v.
Ooh, that was hard, right? 5v. All right.
Made me think a little bit, but it was easy.
So you're taking the coefficients. And you're, okay, let me try this one.
Alright, bet.
Here we go. 6m minus 4v.
You can't.
Ah, why can't you guys do it?
2mv.
Why can't you do it?
Because they're not like.
They're not like terms. Guys, if I was to expand this out, wouldn't I do this? m plus m plus m plus m plus m plus m.
M&M.
And last time I checked, M&M was 2m. It's not 6, right? So just minus v minus v. Does that work?
Wouldn't it be just 2?
No.
2mv?
You can't do anything. Or, even something like 2x plus 1y, right? You just have x plus y. There's no, don't say, oh, 2 plus 1, 3xy. No, there's no 3 of anything. Don't get the algorithms mixed up. You're adding 2 terms, and you have to say there's 2 x's and 1 y. There's not 3 of anything.
So that's equal to 2xy.
This is simplified. You can't do anything more with it. Okay, that's a simplified expression. There is no parentheses, and there's no like terms. That's simplified. Okay? So that's what we're going to be talking about today. All right, now it's going to get a little more challenging, but I wanted to kind of start off with some basics. All right, basically, why do terms have to be alike to add them? And here's why. That's it. Explains it. Okay? All right. So here's what I'd like you guys to do, is to go ahead and grab page 185 worksheet. Oops. Let's go ahead and get a new one here. Put your name up at the top.
I put 2017.
Okay. Now, listen carefully. All right, if you guys take a look at this worksheet is a fantastic worksheet on like terms. That's why we use it here in 7th grade for Math 7. We feel that in a lot of ways it's better than what the book offers when it comes to different types of problems. It's more at your level. It's more what's going to be on the test. It's to get you prepared. Unfortunately, the title, of course, it has to do with the holiday season. All right, you do not have to answer that if you don't want to. If it's offensive, just scribble it out. We're not using it for this at all. We're using it for the problems. Okay? So, here is what I want to show you guys. Okay, let's go ahead. First of all, I want to explain the format of this. This worksheet isn't multiple choice, but it's more like matching. So, meaning that these 2 problems here, the answer is going to match up with 2 of these 4 in here. These 4 here will match up with 4 of these 6 in here. Okay, so it's like matching. So you're going to still solve it, but you're going to be able to find the answer over here and write the letter as well. Okay, so here is what I want to do. Let's go ahead, and I want you to take a look at problem number 6. Now, here's what I want you to do on this first one. I want you to go ahead and take your pencil, put it down. I just want you to watch. Okay, when I go to solve number 6, okay, when I go to solve number 6, here's what I'm going to do. I'm going to look at it, and I have to, there are some parentheses there, but that's not the main issue. The main issue, there's some like terms that I have to combine to simplify it, right? So here's what I'm going to do. The very first thing I'm going to do, and this wasn't in our earlier lesson, but it is something that we've talked about all year long, and that is I'm going to get rid of double negatives, meaning a subtraction sign next to a negative sign. And I know the format of this, I don't want this to confuse you guys. That is a negative 5n. Okay, they just want you to know the difference between subtraction signs and negatives, I guess. So they put the negative as like a superscript or like up top. Okay, it's still a negative. So here's what, this is a double negative. I'm going to go ahead and convert it to a big plus sign there, and I'm going to convert this double negative into a big plus sign. Now what I'm going to do next is, as we keep our pencils down, I'm going to go ahead and I'm going to use, and this is where you can be creative on this lesson if you want. I'm going to go ahead and go to the first term, which in this case is a 9. I'm going to identify it as a constant. I'm going to circle that constant. Then what I'm going to do is I'm going to go through this whole sentence here, this whole expression, and I'm going to circle all of my constants with the sign to the left. So in this case, that's not a constant. It has a variable. That also has a variable, but that is a constant. I'm going to circle it. I'm going to like use a code. I'm going to circle all my constants. Then what I'm going to do is I'm going to go to the very next term, negative 6n. That is an what I'll call an n term, meaning a term that has the variable n. I'm going to box it in with the sign in front, negative 6n. And then I'm going to turn around and box in all my other n terms. Well, there is only one other term, and that's a positive 5n. I'm going to box it in. And then here's what I'm going to do after I basically code it, is I'm going to match up all of my circled terms and all my constants. 9, and then I use the sign in front. 9 plus 8 gives me 17, a positive 17. And then I have a negative 6n plus 5n. So I look at my coefficients. Negative 6 plus 5 gives me a negative 1, or negative 1n. Now when I look here and match it up, there are no 17 minus 1n. But remember what we talked about earlier, I can flip-flop these two terms, meaning I can put my negative 1n in front of my positive 17. Well, there's nothing that matches that exactly right, but I also told you guys the negative 1n is also going to be written as negative n, and look at here, negative n plus 17. So this is my numerical answer. My letter answer is U. And I have my two answers. Okay? So before we ask questions, we're going to go step by step here. Let's take a look at problem number 8. Problem number 8. And this one is the one where you want to grab your pencils and write this down. Here we go. Okay, over to the side, I'm going to put step 1. I'm going to put a little star by it, and this is just more of a reminder than a step. And we'll say, write a little note, double negatives. Okay, eliminate all double negatives if they pop up. Not all of them will have double negatives. So if I look here, the only double negative I have is the minus negative t. Make it into a big plus sign. Okay, step 2. Okay, go to your first term, and again, you can pick whatever. If you want to underline it, put a squiggly mark around it or under it. If you want to put a triangle around it, feel free to do whatever you want. Get creative if you'd like. I wouldn't spend too much time on it. Okay, I'm going to circle, and I'm going to go ahead and circle then all of the rest of my t terms. So in this case, let's see, the plus t, I'm going to circle it. And look at this. This has 3 t terms. I'm going to circle my positive 9t. Okay, step 3 is I'm going to go ahead and repeat step 2, but with the next term. So in this case, it's the positive 7. Okay, maybe what I'll do with this one is I will put like a triangle around it. Okay, doesn't matter. All I'm doing is I'm separating them, basically is what I'm doing. strategically. Now I'm going to go ahead and, of course, put triangles around all of my constants, meaning just my numbers. Well, guess what? There are no more. Okay? Now comes step 4, and that is I'm going to combine like terms. So here we go. Now, guys, we talked about, and you're more than welcome to continue to use T-charts if you're still struggling with integers. But remember what I said, it is the new math facts. By the second semester, if you have not been really taking integers seriously, you can use a T-chart. Feel free. I want accuracy is most important. But in our lessons, you're not going to see me use T-charts very much anymore. Okay, I'm going to use mental math. So here we go. What I have here is a -2 plus, remember, this is 1t. So -2 plus 1 gives me a -1. And -1 plus 9, okay, -1 plus 9 gives me 8. So it ends up being 8t's. And then I'm going to combine all of my constants. Well, in this case, right, there's only one, so I just write it over here. And I have 8t plus 7. Now what I'm going to go ahead and do, and we'll call this a step, we'll call it step 5, is you have your one numerical answer, and then just go ahead and match it up, make sure it's here, and write your letter answer. So 8t plus 7 is also A. So you'll have your 2 answers. Okay, before I let you go to the next problem, any questions on any of those 5 steps? Okay, go ahead and I want you to try out problem number 15. Number 15. All right, go. How many of you still need more time? Okay, all right, give you about 30 more seconds. Okay. All right. Go ahead then and turn to your neighbor and share both, of course. Actually, I want you to share, you can share your answer and your letter answer, okay? But I want you to share, and here's one of the biggest mistakes people make is when they do this, here's what they do. They do not include their sign in front, which is very important considering that is not a positive 3, it's a negative 3u. And when you simplify it, okay, you combine like terms, that is very important. So when you share your work with your neighbor, look and make sure your neighbor has each term circled with, or boxed in or whatever, with the sign to the left, okay? And of course, share your answer, right? 30 seconds. Go ahead and turn to your neighbor and share. Go. Okay. All right, so when we share here, I'm going to go ahead and pull a stick. What I'm going to do is I'm going to say, okay, well, on number 15, the first term is 8K. All right, so I'm going to go ahead and box that in. Now, when I pull a stick, I want, actually, I'll even do the first step for you guys, right? There was a double negative you should have gotten rid of, which is the negative or subtraction of negative 5K, right? So what I want you guys to do is the first person I pull is, I want you to tell me what else do I need to box in, if any. Okay, so meaning what are all the like terms with 8K? All right, so seat 40 is not in this class. All right, seat, let me go, 23. So which other terms should I box in with 8K? Negative 8. All right. So box in negative 8. Is that it? Okay, agree, disagree. Okay. Anyone have a different answer? All right.
5K.
What is it? 5K. Okay. Agree, disagree there. Okay. All right. Anyone else want to share? Nico?
The 5K, but the plus sign too.
Okay, so the 5K with the plus sign as well. All right, negative 8?
No.
No? Okay, is that it?
No.
And what else?
Negative K.
Negative K? Okay, why are those three the ones that we box in?
Because they're all like terms.
They're all like terms. What makes them like terms?
They all have a K.
Okay, all right. Agree, disagree now with those boxing. Okay, see, almost all of you guys agree at this point. Okay, so those of you that shared, thank you guys very much. But obviously, any questions about those? We see they're all K's, right? We need to make sure we have the signs in front. Guys, by the way, everyone, what can we squeeze here between the negative and the K?
1.
A 1, yeah, a 1. And you might want to do that to help you simplify, right? Okay, now I'm going to go ahead then. I'm going to go ahead and I'll circle my other like terms. So this person, go ahead. I'm going to choose another stick. What are the like terms I need to circle? All right. Seat 2. The plus 7 and the negative 8. I like how you said the signs as well. That's awesome. Agree, disagree. What do you guys think there? All right. They are, what was the word for just numbers again? They are what?
Constants.
They are constants. Thank you, guys. They're constants. Okay, without a variable, and that means they're like terms. So we circle them with the sign in front. Okay, so now we go ahead and combine them. So I'm going to actually combine at this point. So 8 minus 1, I'm doing all my k's first. So 8 minus 1 gives me 7. 7 plus 5 gives me 12k. And here I have 7, positive 7 minus 8. That gives me a negative 1. So it's minus 1. 12k minus 1, there it is. Letter I. Okay, questions? All right, guys, so simplifying algebraic expressions, or like I said, combining like terms.